Why is quantum measurement of qubits so confusing? Imagine trying to measure something that doesn't stay still or even stay the same. That's what happens when we look at qubits in quantum physics. Unlike regular bits that are either 0 or 1, qubits can be both at the same time, thanks to a property called superposition. This means when you try to measure a qubit, it's not just about finding out if it's 0 or 1. Instead, you're forcing it to choose one state from many possibilities. This act of measurement actually changes the qubit state, which is very different from how measuring a regular object works. In classical physics, measuring something doesn't change what it is. But in quantum mechanics, the moment you measure a qubit, its wave function collapses. Before measurement, the wave function describes the probabilities of the qubit being 0 or 1. Once you measure, the wave function collapses into a single state, either 0 or 1. This probabilistic nature makes it tricky because you can't predict the exact outcome every time, only the chances of each result. There are different types of measurements too. Full system measurements look at all qubits at once, which can be very complex. Mid-circuit measurements happen during calculations, helping to correct errors or guide the process. Partial measurements focus on just one or a few qubits, often used to check if everything is working smoothly. Each type of measurement has its own rules and effects, adding to the confusion. Heisenberg's uncertainty principle also plays a part. It says that certain properties, like a particle's position and momentum, can't both be known precisely at the same time. When you measure one property more accurately, the other becomes less certain. This principle shows that measurement in quantum systems isn't just passive observation. It actively influences the system itself, making the process even more puzzling. Understanding how qubits behave during measurement is essential for developing quantum computers and quantum communication. It's the key to turning the strange rules of quantum mechanics into useful technology. But because measurement involves collapsing superpositions and changing states, it's no wonder that many find it confusing. It's like trying to catch a shadow that keeps shifting just as you reach out to grasp it. That's the challenge and the wonder of quantum measurement of qubits.